Welcome back again to Gas Law Class 2. Here we're going to talk about the Dalton's law of partial pressure. Now, in the previous video, I talked about the Boyce-Charles and the ideal gas equations, and I made an experimental fact of it. Now, this is the experimental representation of the Dalton's law of partial pressure. John Dalton is a scientist. He's also known as the father of the atomic theory. He formed the atomic theory. Now, he also studied the mixture or the pressure exerted by a mixture of gases. So we are talking about what? Pressure here. And we notice what? Partial pressure. Now, he stated that the pressure exerted by a mixture of gases, there are two gases. The pressure exerted by a mixture of gases is equal to the sum of the individual partial pressure, provided that they do not react at that particular temperature. Now, what do we mean here? He said that the pressure exerted by what? Mixture of gases. So there must be a what? One or two or more gases that will be what? Mixed together. Now, for this container, let's say that we have hydrogen over here. We have hydrogen, and here we have nitrogen. We have nitrogen containing here. Now, this nitrogen here, so this hydrogen exerts its own pressure, and this pressure that hydrogen exerts on its own is what we call partial pressure. This one also containing nitrogen exerts its own pressure. Nitrogen gas exerts its own pressure called partial pressure. Now, when these two gases may be added together or they are put in the same container, so we are going to plus this gas here and this gas here, meaning that we're going to put them in the same container. Hence, we are going to have a what? In the container, we will have hydrogen and we have what? Nitrogen. All of them, both are what? Gases. So here is addition of what? Hydrogen and nitrogen. Now notice that since hydrogen exerts its own pressure called partial pressure and nitrogen exerts its own pressure called partial pressure, at this particular point in place, the pressure that is going to be exerted by the mixture of these gases is going to be equal to the what? The sum of the individual partial pressure of the gases. So here is going to be a total pressure. All right, so the total pressure now exerted by a mixture of gases according to Dalton's law is equal to the what? Sum of the individual partial pressure. Did you understand it? We can now put it in a mathematically as that P of hydrogen I mean to say, plus P of what? Of nitrogen. This is nitrogen is equal to what? The pressure total. Do you get? Now, there could be more than one pressure. For example, there could be more than one pressure. Hence, we are going to have P of 1 plus P of a gas 2 plus P of a gas 3 to how many gas we have. That is N represent how many gas we have. So how many gas you have that come together to react on a mixture, since the total pressure is still going to be the sum of the what? Individual pressure. So that is what Dalton's law is all about. We're going to look at a question at the end of this video. Now I want to talk about when a gas is collected over water. When you collect a gas over water, that gas is being wet with water vapor. For example, when you cook, if you're cooking something, this is a pot you're using to cook water. You want to boil water over here. Now, if you're boiling water, this is the heat that you're applying on this pot here. The water here, when it is boiling, you see that it is going to be what? Evaporating. That is what? Vapor. That vapor is called what? Water vapor. Now, assuming that in an experiment, we want to collect a gas over this water vapor. Let's say, for example, carbon 4 oxide. The carbon 4 oxide or hydrogen gas that we want to collect over this water vapor is going to be wet with water. What we mean by wet? is going to be like slippery, or water is going to be on it. So it's going to be a mixture of what? The dry gas and the what? Water. So it's going to be wet with what? Water. And hence, since water vapor has its own pressure, we are now going to say that for what for gas collected over water over water vapor. All right, when you collect a gas over water vapor, it is going to be what? Wet. Hence, the total pressure of that gas you have collected over water, the total, is now going to be equals to the pressure of the water vapor. All right, the pressure of the water vapor plus that of the pressure of the dry gas. But you have not have the dry gas already, because it is still what? Wet. You need to what? Get the dry gas. So you have plus the dry gas. So if you collect a gas over water, it's going to be what? With what? Water vapor, because water vapor exerts its own pressure. Hence, the total pressure of that gas you collected over water will be the pressure of that water vapor plus the pressure of the gas. Now, to get your dry gas, we are going to say that P of what? Dry gas. We want to make P of dry gas sort of formula. I'm going to say P of what? Dry gas equals to the total pressure exerted by that gas you collected over water, now minus the pressure of what? The pressure of water vapor. The pressure of water vapor will now give you a dry gas, and you must do this particular thing so that you're going to get that particular gas you want to collect over water. So you're going to do what? Separate it from the what? Water vapor by another what? Experiment. But here we only talk about what? The formula. All right, so this is what? Practical representation of Dalton's law of partial pressure. Hope you understand this. So the pressure exerted by a mixture of gases is equal to the what? The sum of the what? Individual partial pressure, provided that what? They do not react at that particular temperature. So temperature must be what? Constant. Now let's look at experimental question. Here is it. So now look at this question. Pay very attentive. This question is not difficult. It's very easy. It's very cheap. Now let's read it together. If 20.0 dm³ of hydrogen, dm³ mean what? Volume, we are collected over water at 17 degrees Celsius and 79.7 kilonewton per meter square pressure. That is the pressure at that 17 degree Celsius. We go again. Calculate the A, pressure of dry hydrogen at this temperature. At that temperature, that is what? 17 degree Celsius. B, volume of dry hydrogen at standard temperature and pressure. That's what we mean by STP. Now you're given in a bracket a tip you're going to use and solve it that vapor pressure of water is 1.90 kilonewton meter square, or sorry, kilonewton per meter square. That is this minus here at 17 degree Celsius. That is what? The water vapor. And you're given that 1 atmosphere equals 101.3 kilonewton meter square. I know at this point you will be confused with all of these parameters here: vapor pressure, standard temperature, and pressure. Please, what does standard temperature and pressure means? Standard temperature and pressure is an experimental condition. Write it down. This is a what? Experimental condition in which an experiment is done without the loss of temperature or the application of temperature, or the loss of what? Pressure and the application of what? Pressure. For instance, where you are watching this video, if a scientist come inside that place near you to perform an experiment, the temperature in that room and the pressure with those gases that you want to perform experiment on is under standard temperature and pressure. But when he start, if he now start the experiment, maybe he's going to increase, he need a heat for the reaction to occur. He has what? Increased that what? Temperature. It is no longer a what? Standard temperature and pressure. He has gotten a new what? Pressure on his what? Reaction. Are you getting me? You're going to understand as I'm going to solve this video. So I'm going to solve this question. All right, we have what? 20 points. 20.0 dmq. We are looking for what? First one said pressure of dry hydrogen at this temperature. Now you remember that I said that if a gas is collected over water, it has a what? Water vapor pressure. So that the P total is equals what? Is equals what? The P of water vapor. I'll write it water V plus the P of what? Gas. So in this case, the gas they want to collect over water is what? Hydrogen. As you can see, hydrogen. Are you getting me? Now, what am I going to do? I'm looking for what? That hydrogen without the water vapor. Like I said earlier, I'm going to make P the subject of P of pressure of hydrogen the subject of formula. So that pressure of what? H gas is equal to what? The P total minus what? Minus the pressure of water vapor. All right, water vapor. Now this is furthermore equals to P of H2, which is what? Gas, and it is a dry gas because here the P total has what? Water vapor. But when I am looking for this value, there is no more water vapor because I'm going to minus the water vapor from the total pressure to have only what? The pressure of the hydrogen gas. Now this is equals to what is P total? Let's read this question again. P total equals what? If 20.0 dmq of hydrogen collected over water at 17 degrees Celsius and 79.7 kilonewton meter pressure. So this is the what? Pressure exerted by what? The gas that was collected what? Over water. So this is the total pressure, and this total pressure contains the pressure of the gas and the water vapor. Are you getting me? So I'm going to put what? 9.7 kilonewton meter square. All right, so that is what? The total pressure, which is what I'm looking for here. I'm going to put it what? 79.7. Now I'm going to minus it with what? Pressure of water vapor. All right, now can we see any value of water vapor here? If you look at the bracket, you're given what? Vapor pressure of water is 1.90 kilonewton per meter square at 17 degrees Celsius. That is at this particular what? Temperature that they collected that water. Water vapor is equals to what? This. What did I mean? Like I put you guys before that when the water is what? Evaporating on heating, it have a what? Water vapor. So that water vapor, the pressure is what? 1.90 kilonewton per meter square. All right. So I'm going to minus it, which is what? 1.9. So I'm going to put pressure of water equals what? 1.90. Hope you're understanding. So now once you use this and minus this, you're going to have a value. This minus this will give you 77.8, and pressure is measured in what? Kilonewton meter per square. All right, this is a what? Higher pressure. That's why we put it to what? Kilonewton meter per square. So this is what? The pressure of what? Dry hydrogen. Hope you understand. From the formula we have gotten what? Pressure of what? Dry hydrogen. Now in part B, we have the volume of dry hydrogen at STP. That is standard temperature and pressure. But first of all, let us write what we have at not this condition. That is, when this condition has not yet come, what do we have? So now we have to state given data. At the stage that is not, STP, we have that the volume V is equals what? 20.0 dmq. At that stage, that's not STP. That is when it was collected over water. Now, at that same state that it was collected over water, the temperature was 70 degrees Celsius. So that T1 is equals what? 17 degree Celsius. Now you convert this to Kelvin scale. Converting it to Kelvin scale, a 0 degree Celsius is equals to 273. Now, since we have 17 degrees Celsius, it's going to be 273 plus 17 degrees Celsius will now give us in Kelvin. But if this 17 degrees Celsius is greater than 273, we minus 273 from 17 degrees Celsius. So because it is lesser than 273, I'm going to say 17 plus 273. And this, if I work it, is now going to be in what? Kelvin. So that this is equals what? 1 plus this 7 is going to give us 8. 7 plus this 3 is going to give us 10. Now, 10 plus that 8 is going to give us 9. I'm going to have 290 Kelvin. At the stage, that is not what STP. That stage is what? When it was collected over water. What again do we know? We know what? Pressure. We know what? Pressure. And we know P1. What is P1? Remember, we are talking about what? We're talking about the hydrogen gas. All right. So the pressure of that hydrogen gas at this stage, they say that we have 79.7 kilonewton over meter square pressure. Remember that this pressure contains water vapor pressure and the pressure of what? Hydrogen. But we have calculated the pressure of dry hydrogen. What was the pressure of dry hydrogen? The pressure of dry hydrogen was 77.8 kilonewton per meter square. All right, that is what? Under non-standard temperature and pressure. This is what the condition that the water was collected over water, sorry, the gas was collected over water was. Now, what do we now need to find? We now need to find in standard temperature and pressure the volume of dry gas. So V2 is equals to what? Unknown as standard temperature and pressure. Now, as standard temperature and pressure, we are going to get another T2. We are going to get another what? T2 at that standard temperature of pressure, and vapor pressure at what? At standard temperature and pressure, the temperature that is suitable, and it is 273 Kelvin. That is a standard temperature and pressure. A condition that is well what? Acceptable. The temperature should be what? 273 Kelvin, but it was not what? Stated over here. But you should know that. All right. Now, what again is going to happen at standard temperature and pressure? We are getting the standard temperature. It remains the what? Standard pressure. And it says that 1 atmospheric pressure is equal to what? 101.3 kilonewton meter square. That will be our what? P2. That is, that was standard temperature and pressure. We need to calculate the what? The volume. Remember that from here and above is what? Non-standard temperature, where it was collected over water. So that the P2, that is atmospheric pressure, is equal to what? 101.3 kilonewton per meter square. All right, so now this is the variables that we have over here, and this here we have volume, temperature and pressure. Volume, temperature and pressure. The formula suitable here is the idle gas equation. Idle gas equation is the combination of both Boyle's, Charles and what? This combination of both Boyle's law and Charles' law. I get him. Now, it means that the temperature and pressure are not constant. So we are going to use what? P1 V1 over what? T1 equals P2 V2 over what? V over what? T2. In my first video, I made an explanation what this means. I made explanation the meaning of this P1 V1 over T2, what it means experimentally. I'm not going to talk about that here. Go and check the video and you can watch it. All right, so that this is what we have here. We want to replace everything or substitute the variable that we have here over here. Now, P1 is what? 77.8. So I have 77 0.8 multiplied by V1. What is V1? 20 point, just let's put it as 20, or let's put it 20.20 because you might be confused. Now it's going to be equals what? And from here it is over what? T1, which is T1 is what? 290. Now again, we talk about the standard temperature and pressure, whereby we're looking for what? V2. V2, that is standard pressure, is equals what? 101.3. And it's going to multiply what? V2, which is what? Unknown. We don't know what V2. We divide by what? We divide by T2, which is standard temperature, which is what? 273 Kelvin. Don't put the unit when solving. All right. So what are we going to do now? We're going to make what? V2 the subject of the formula. Hence, we close and multiply. All right. So what are we going to do now? If this multiplied by this, we are going to have that what is going to remain here is going to be here multiplied by here, or this other side here multiplied by this side. We are going to have what? We're going to have 290 times 101.3 times V2, and it's going to be what? Equals to this whole parameters times this over here is going to give us what? It's going to give us 7.8 times 20.0 times 273. All right. Now, because we are looking for what? V2, we need to divide the both side by what? 290 times 10, 1.3. This will cancel this. Whatever you divide there, you divide it, remember? So we're going to have also divide this by 290 times 10, sorry, yes, 10, 1.3. And that is what is going to be there. Now, once you cancel this and cancel this, you say V2 is equals. Now, in your calculator, you're going to place 77.8 times 20 times 273 is going to give you a variable. You divide it by 290 times 101.3. Once you do this, you're going to have your answer to be 14.5. 14.5. This is the final answer. This is the word volume of the gas at standard temperature and pressure. So that is the answer for this question. That is the final answer here. Please guys, don't forget to share this video to your friends and let me know what you think on the comment section. I don't like the fact that you always see my video, you don't comment on the comment section. Please comment and like this video. Bye bye.